what we're getting into now. We're going to do circles. Now, you guys have already done some stuff with circles, but we're going to expand upon your knowledge. Okay, we're going to expand upon your knowledge of circumference and area, okay, to solve some real world problems. Oh my gosh, I already need chocolate, you guys. Okay, and we're also going to look at parts of a circle, including some that you may already know and some that you don't know. Okay, so let's dive in. Let's take a look. So first of all, guys, there's something that you need to know about in geometry. Everything has like a symbol for the way it's named, right? Well, when we name a circle, we use the center point, okay, and we use this symbol right here, okay? That is circle P, okay? Notice that the point that's in the center of the circle is how we name it, okay? All right, now, most of you have already heard of and you remember what a radius is, right? A radius goes from the center to the outside of the circle. Now, something that you guys may or may not have heard of before is called a chord, okay? A chord is a line where both of the endpoints of that line segment are on the outside of the circle or the edge of the circle, okay? So, having said that, well, guys, isn't the diameter, there's an endpoint here and an endpoint here, isn't the diameter also a chord? Yes. Now, what's special about the diameter is that the diameter has to go through the center of the circle, okay? Now, guys, you probably already remember this, but just in case, okay, did you guys remember that the radius is 1/2 of the length of the diameter? Or another way that I could say it is 2 radii equals the length of the diameter. Did you guys remember that? Okay, so just in case, and guys, these are saying the exact same thing, okay? So the radius is half the length of the diameter, or 2 radii make up the length of 1 diameter, okay? Now, here's a new one for you guys. I bet that most of you have not heard of what's called a tangent line. No, it's not the same tangent as trigonometry, what we do with trigonometry. This one is a physical line, okay? So a tangent is a line that intersects a circle at exactly 1 point, okay? Exactly 1 point. The chord intersects at 2 points, doesn't it? Okay, a tangent only intersects at 1 point. So right here, you guys will see this line touches that circle at exactly 1 point, okay? Now, a tangent, okay? A tangent is, or excuse me, a line rather, is tangent to the circle if and only if it is perpendicular to either the radius or the diameter, okay? Now, we're going to use this here in just a second because, guys, we're going to create right triangles and we're going to solve for some measurements, okay? So, you have a tangent line if and only if it is perpendicular to the radius and touches the circle at exactly 1 point. Now, here's a new one for you guys. If we have 2 tangent segments that touch the same circle, okay, so right here it touches, right here it touches. 2 tangent lines, and both of those tangent lines come from the exact same point, then these 2 lines, the tangent lines, have to be congruent. So that means that if this side length is, we'll say 6 feet, then this side length is also 6 feet, okay? Now, believe it or not, guys, these properties of tangents are used a lot when we're dealing with satellites that are orbiting the Earth, okay? They use these kind of lines to help us figure out the orbital, what do you call it? The orbital altitude, I believe it is, of satellites. Okay? See, you guys are learning space stuff already, right? All right. Now, let's talk a little bit more about something that you guys already know about. You guys have already practiced with circumference, and you've already practiced with area of a circle. So, just as a reminder, you can find all of these formulas in your formula chart, okay? So, the circumference of a circle can be calculated 2 different ways. The circumference of a circle equals pi times the diameter, or the circumference of the circle equals 2 pi times the radius. And hey guys, that's because 2 radii equal 1 diameter, don't they? Okay, so, all right, area is always pi r squared. Wait a minute. Hey guys, I thought that pi are round. I didn't know that pi are squared. Miss Smith, you're so funny, right? Okay, so that's just a little joke. Area equals pi r squared. Now, here's something super important in this class. Okay, guys, I cannot stress this enough. When we are using pi, okay, use the pi button on your calculator. Do not round it. Do not use 3. Do not use 3.14. You are going to use pi unless the problem tells you specifically to use 3.14. You're going to use the pi button, aren't you? Yes, Smith, we're going to use the pi button. All right, good job, you guys. Good job. All right, you guys ready to dive in some problems and see how this all works? Yes, of course you are. All righty, let's go down. And hey, guys, let's start with number 5. Go down to number 5 with me. Okay, so down here at number 5, before we do number 5, we've got to read the instructions. It says, determine whether or not line segment PQ is tangent to circle R. All right, then we got to show all of our work to prove it. So if I zoom in here on number 5, it says, is PQ a tangent line? Yes or no? All right, so ladies and gents, earlier I was just talking about there is something that must be true if the tangent line intersects the radius. What must be true when those 2 lines intersect? Okay, hopefully you went back and you looked at your notes and you said, hey, Miss Smith, or I remember, Miss Smith, you said that the radius and the tangent line have to be perpendicular. Okay, so if they are perpendicular, then this particular triangle PQR, would be a right triangle. So we're going to test and see, do we have a right triangle? Okay, and if we have a right triangle, okay, if we do, then yes, the line is tangent, okay? But if we don't, okay, if we don't have a right triangle, then the line is not tangent. Well, how do we determine whether or not we have a right triangle? Well, hey, guys, think back to Unit 9. We tested to see if we had an acute, obtuse, or a right triangle. We used the converse of the Pythagorean theorem. You're going to do the same thing here. Hey, remember this. Remember we said c squared, box, and then a squared plus b squared. So we're going to plug this in and see, does c squared, it has to equal a squared plus b squared in order for it to be a tangent line. Okay, hey guys, work your magic. I want you guys to plug this in, and I want you to tell me, are they equal? They're not equal, are they? No. So if they're not equal, that means that this is not a right triangle because a squared plus b squared does not equal c squared. So that means that no, this line segment PQ is not tangent to circle R. Okay? All right, so you're going to test those on 4 through 7, and you're going to see whether or not you have a right triangle. Okay? All right, let's go down, and hey, y'all, let's go look at number 8. I'll meet you guys down at number 8. Okie dokie. All right, so we're still dealing with tangent lines. It says, line segment MN is a tangent. So we know that it's a tangent line. It says, find the radius of circle O. So that means we want to find the length of the radius. Hey guys, we get to have some fun with our algebra skills on this one. Okay, so let's zoom in on number 8 and take a look. It tells us that line MN is tangent. So if MN is tangent to the circle, so that means that MN and ON have to be perpendicular. That means that we do have a right triangle. Okay, I'm going to zoom in even more so you guys can see something. Hey guys, I want you to tell me, think back to what do you remember is always true about the length of radii that are inside the same circle. What do you guys remember? Hey, this goes back to your previous knowledge about what you learned about circles, right? Before. All radii in the same circle have to be congruent. So that means that if this radius is labeled as r, then this radius right here should also be labeled r, because that's our radius. Okay, so something to remember there. Now, guys, if you look, we have a right triangle. Now we're going to see, okay, and solve for r using the Pythagorean theorem. This is where our algebra skills get to, woohoo, we get to show it off. Okay, so we're going to set it up. A squared plus b squared equals c squared. Okay, that's our Pythagorean theorem. We're going to use that to solve for r. Now we got to figure out, what are we going to plug in for a, b, and c? So guys, if you remember, a and b are always your legs. Okay, so right here is one of your legs. Right here is the other leg. So I would say r squared plus 15 squared equals. Now, here's where it gets interesting. Guys, the hypotenuse is this whole entire thing. The whole entire thing. Oh, well, hey guys, this goes back to unit 1. Do you guys remember? How would we find the length of that whole thing? Well, part plus part equals the whole. So this would be 12 plus r. Oh, so that means that c is 12 plus r, that whole thing squared. Okay? Now, let's work our algebra skills. I'm going to do this with you guys. Okay? So we have r squared plus 225. Okay? Because 15 squared is 225. Now, when we say 12 plus r squared, that means that I take 12 plus r and I multiply it times itself. Okay? Oh, maybe some of you remember this. I'm going to zoom in right here. Do you guys remember the FOIL method? Or some of you learned it as double distribution. Okay, so we're going to go through and we're going to solve this. Okay, so r squared plus 225 equals. Okay, on the right-hand side, okay, we're going to do the first term first. We're going to multiply 12 times 12. Well, guys, 12 times 12 is 144. Okay, and then we're going to multiply 12 times r. Well, guys, that would give me positive 12r because both of them are positive. Then we're going to multiply the second term. So r times 12. Oh, well, r times 12, they're both positive, so that's plus 12r. And then we multiply r times r. R times r is r squared, and they're both positive, so we do plus r squared. Whew, okay, all right, we're practicing that algebra. Okay, now, before you can add or subtract, remember, guys, you have to combine like terms. So I have a like term right here and right here, don't I? Okay, now I'm writing out all the steps to show you guys. Okay, so r squared plus 225 equals 144 plus 12r plus 12r is 24r plus r squared. Oh my goodness, okay. Oh, hey, okay, we've combined the r's. Now, hey guys, we've got an r squared over here and an r squared over here. Well, if we subtract r squared from the left, so I subtract r squared. Oh, let me rewrite this so it doesn't look like I'm dividing. Okay, I subtract r squared from this side. I subtract r squared from this side. Hey guys, they cancel out. They go away, don't they? Oh, okay, this is getting a little bit easier, Miss Smith. I get this. 225 equals 144 plus 24r. And now that looks a little bit more manageable, doesn't it, guys? Okay, so you guys solve it from here and tell me, what do you get for the measurement of r? Alrighty, did you guys remember to round to the nearest tenth? Okay, the instructions, if we go back up here and look, round to the nearest tenth. So for r, you should get that it is 3.4. And guys, there's no units, so my final answer is 3.4. All right, hopefully you guys remember to read the instructions. Okay, I'll let you guys do number 9. It's very similar to number 8, but I showed you guys step by step how to work that out. All right, let's do another one, Miss Smith. Let's go down and let's look at number 11. Okay, do number 11 with me. Okay, on 11 through 13, or 10 through 13 rather, guys, these are a little bit different. So we're going to find the indicated measure, okay, and we're going to show all of our work, including the formulas, ladies and gentlemen. Okay, that's not optional. We must write down the formulas. And there's a reason why, because these formulas are going to help us to find what we're looking for. Okay, so right here, if I zoom in on number 11, it says find the circumference of a circle with an area of 900 pi meters squared. So the very first thing it says, I'm looking for circumference. That's what I need to find. Okay, so circumference equals, I could do 2 pi r, right? Circumference equals 2 pi r. Okay, guys, I don't know the radius. I don't know the radius. What I do know is area. Okay, well, let's write down the equation for area. Area equals pi r squared. Hey, guys, now we know the area. So since we know the area right here, we can go and plug it in for area. So that means that the area is 900 pi equals pi r squared. And now we can solve for the radius. And then once we have the radius, then we can find the circumference. Okay, very first thing, I got to get the radius, I got to get the r all by itself. So I'm going to divide both sides by pi, and looky there, those pi's cancel each other out, don't they? Okay, so now we have 900 equals r squared. All right, hey guys, then what would r be? Yeah, once we take the square root of both sides, r is going to equal 30 meters. Okay, so the radius is 30. Now I should probably go and find the circumference. So what we're going to do, now that we have the radius, now we can go and plug it in. Okay, so you guys are going to plug this in. It's going to look like this. Circumference equals 2, come on, Miss Smith, 2 pi, and the radius was 30. All right. Hey guys, you can put that in your calculator just like that. Now here's the question. Did you remember what I said about pi earlier? Let's see. What do you guys get for the circumference of this circle? And hey, your units are going to be meters. So tell me what you get, including the units, for the circumference of this circle. Did you guys remember to use the pi button and not use 3.14 in your calculator? All right, hopefully you remembered that. Okay, so the circumference is 188.5 meters. Okay, so guys, I want you to make a little note to yourself wherever you make it. Okay, I'm going to give you something to write here. Okay, so the radius and the diameter, okay, the radius and the diameter are going to be in single units. Okay, and what I mean by that is they would be in like meters or feet or inches, single units. Okay, the circumference, if I can spell this, you guys know this is why I teach math and not English. I can't spell. The circumference is going to be in single units, like meters or feet or inches. Okay, and area, okay, area is going to be in squared units. So it would be like meters squared, feet squared, or inches squared, squared units. Okay, so if you guys need to write that down somewhere to remind yourself of that, then please do. Okay. Okay, there are some word problems. Yes, word problems dealing with circles that you guys are going to work out during class. Okay, you're going to finish this assignment during class, and you're going to ask as many questions as you need to in order to be a master of circumference, area, and parts of a circle. All right, until later, adios!